Welcome to today's episode on STEM Cubed, where we talk about science, technology, engineering, and math, symbolic logic, theology, economics, and medicine, as well as sociology, techniques for teaching, education, and more. We have STEM Cubed with Amos the Math Guy. We're going to do the history of math, the history of science, the philosophy of math, the philosophy of science. Like, you're going to be getting a college education on the side for fun. And by the way, I help students get up to 60 college credits before they graduate high school. If you want to see that plan, email amosthemathguy@gmail.com. I have a plan that covers all core subjects, English, math, history, science, in partnership with a university in Texas. So reach out for more information. This is Amos the Math Guy. And you can sign up for my courses at amosthemathguy.com. Enjoy today's episode where we talk about some of the ways we can teach the history of science as it connects to mathematics. Enjoy the episode below. When it comes to teaching math and science with a historical perspective, people might say, how do we do this? How do we introduce this to our students? Well, I'm going to give you a practical example. What we're going to do here is we're going to talk about Benjamin Franklin and other innovators and inventors, and we're going to try and understand how understanding their historical context could have affected the work that they did. So let's get started. My name is Amos the Math Guy, and what I want to do in this video again is to show you how we need knowledge to be integrated: history, writing, history of math, science. We need an understanding of education that involves an integrated approach, a classical approach, understanding where we've come from as a society and where we're headed. So let us begin. These are just some resources I have on technology. Technology in America, inventions from outer space, and then Benjamin Franklin's autobiography. He was a great inventor, right? So we need to teach about people who were inventors and understand how they thought so that we can inspire our students to think like that. Okay, so we have more books here of Western civilization, and we have the Bible, because some of the stories of the Babylonians and the Egyptians, actually you can learn things from the Bible about these people as well. You learn about the pharaohs and Joseph. You can learn economics from Joseph, which is a wonderful story in the book of Genesis. But this is one of the reasons why I'm doing this particular video. This man on this page is Antoine Lavoisier. So Lavoisier, the book here, subtitle says, The Birth of a New Science in an Age of Revolution. See, Lavoisier was living in a time where things were getting tumultuous in France. And so in the 1700s, we get the French Revolution. And around in the 1790s, unfortunately, Lavoisier was killed. He was killed because of, just think about some of the tensions going on and questions of submission to absolutism and the problems that France had at that particular time. Let me mention two quick things. This is called A Tale of Two Cities by Charles Dickens. And again, notice that that's literature, but it ties a little bit to what's going on in the world in the 1700s. Because now in the 1700s, you kill the man who's like the father of chemistry. And look what it does to the history of chemistry, right? Look at the history of chemistry and look at the history of physics. You begin to notice some disjointedness that occurs because one of the main people involved in the history of chemistry is killed. When you say things like calcium chloride, when you name compounds, and when you talk about certain pieces of chemistry, that actually goes back to Antoine Lavoisier. So there's a book here that not only talks about Western civilization, but it talks about some of the implications. That's where philosophy comes in. So notice Amos the Math Guy here, but we are talking history, literature, philosophy, humanities, science, math. That's the way I want us to learn, is that let's take a time period like the 1700s and let's discuss the different aspects of the 1700s that gave us what we have today. Now, someone might ask, how does this make me a better scientist, right? Some people are really into their science and they're like, you're wasting my time. Because if you understand the history of science, you will learn some of the things you shouldn't be doing so you can actually make greater progress. Dedicate some time to the history of science and your skills will get better and your thinking will get better, right? That's what I've noticed in the study of the history of science. And so this is what Francis Schaeffer has to tell us. He has all these topics: the Middle Ages, the Renaissance, the Reformation, the Enlightenment, the rise of modern science, the breakdown in philosophy and science, modern art, music, literature, and so on and so forth. But it's so cool because a philosopher now is reflecting on some of the things that happened in the scientific revolution and the French Revolution and so on and so forth. So how does this work on a practical level? We learn a concept, so like let's say electricity and magnetism, which by the way around this time was growing. We talk about people like Volta, we talk about people like Ampere, we talk about people like Michael Faraday, and they lived around this time. Michael Faraday is one of like my best friends in the history of science. Very humble beginnings, very poor, but Michael Faraday rose through the ranks by being dedicated and diligent and taking initiative. See, Michael Faraday only had like a middle school education, but he knew of a man called Humphrey Davy. And Humphrey Davy used to do experiments and different things for the public in London. And Michael Faraday went to these lessons, took notes of what was going on, and then he wrote a letter, or he reached out to Humphrey Davy and said, will you give me a chance to work for you? So Michael Faraday got an opportunity to work with Humphrey Davy, and then he did his job well, but then he also did his experiments over here on the side, and he started building and growing, and eventually Michael Faraday started giving Christmas Day lectures. He used to do lectures for the public. Some of those lectures you can actually find on YouTube. Someone has acted them out, but that's the way Faraday would have taught. He was a wonderful teacher. But Faraday did not know mathematics like another man I'm going to talk about. So we're talking about electricity and magnetism. We're in the 17 into 1800s here. Napoleon has come. Mechanical engineering, Sadi Carnot. Some things are happening in France. So around 17 into 1800, Faraday is moving up in the ranks. And a young boy is born, or a boy is born in Scotland. His name is James Clerk Maxwell. James Clerk Maxwell is the greatest mathematical physicist ever. Like ever. Now you're like, how could you say that? Without James Clerk Maxwell, there's no modern physics. Like there's none. How? Because he realized that light was electromagnetic radiation. He also told us about the rings of Saturn and what they were made of, and we didn't find out till 100 years later. James Clerk Maxwell was so good at math that at 15 he was he published a paper and he had to have someone else read it. I mean, this guy was 15. I just love Maxwell. And Maxwell met Faraday. And Maxwell gave Faraday the mathematical explanations of some of the experimental physics that Faraday was doing. I mean, how crazy is that? That's like the greatest meeting in science, I would argue. Because Faraday had the experimental skills. And remember, he took initiative, he did what he did. By the way, at the end of his life, the Queen gave him a house. He went from a poor man to dying, having a house from the Queen. When he died, though, he wanted to be in a small funeral, leave me alone, kind of guy, very humble. And then James Clerk Maxwell comes, and the guy was so good at math. Someone once said, can you ever be wrong on your math? Like all his math was just checking out. Maxwell was phenomenal. He died in 1879, which is the year that Albert Einstein was born. Galileo, by the way, died in 1642, which is the year Newton was born. Isn't that interesting? If you look at the history of science now into the 1800s, James Clerk Maxwell, look up his Wikipedia page. You're going to see like Maxwell Boltzmann, Maxwell this, Maxwell that. Even radio waves, like Heinrich Hertz, the work he did, some of that goes back to James Clerk Maxwell. When they asked Albert Einstein one time, whose shoulders do you stand on? Do you know what Einstein said? I stand not on the shoulders of Newton. I stand on the shoulders of Maxwell. Maxwell's equation, someone said, Richard Feynman said, many years from now, when our civilization is done, one thing will remain, Maxwell's equations. That's the guy, James Clerk Maxwell. And then Michael Faraday. So the two of them meet. And Maxwell does what he does with the equations. And there's differential equations involved, which is tied back to calculus, which is tied back to Isaac Newton. So Newton, in a sense, gave Maxwell an alley-oop, and Maxwell dunked, right? That's just the way math works, and the history of science is that we're learning from people who have come before us. Okay, I need to wrap this all up. So you're learning a concept like electricity and magnetism. You take a book from IEW called Modern World History-Based Writing Lessons, where it will talk about the French Revolution, for example, and you can write about it. And you can write about Antoine Lavoisier as it ties into the French Revolution. Do you see how we're tying literature and writing into our science? And then you take some original textbooks like Leonard Euler's book, which was written around 1750 before the French Revolution happened. This is Euclid's book, by the way. Euler and Euclid, there's some connections with their work in number theory. But you take a writing course, you connect it with some primary documents and some stories of people like Antoine Lavoisier, The Tale of Two Cities. But see, what we're doing is we're reading about The Tale of Two Cities. We're reading about the time in history using an actual history textbook of the 1700s. So you're reading about the 1700s. You're writing about the 1700s. You're doing math from the 1700s. You're doing chemistry from the 1700s. You're reading literature from the 1800s, right? So look what we've just done. We've created an integrated approach to learning about electricity, magnetism, and the history of chemistry. That's the way we need to go about this. An integrated approach to learning. And then you're learning the philosophy and the implications of humanism This right here is how people need to learn. An integrated approach to learning. That's what Amos the STEM guy is about. This is my book, Tools for Mastering Mathematics. You can email amosthemathguy@gmail.com if you want a copy. You can also buy it, or if you want to support the work that we're doing, feel free to use the link in the description or reach out to amosthemathguy@gmail.com. But here's what it comes down to. We need to inspire students like never before. Information is readily available. That's not our problem. Our problem is that students sometimes don't care, and they don't care because they don't see the point. We need to show them the point, and part of showing them the point is maybe giving them a historical context. By the way, the greatest musicians, some of the greatest artists, and the greatest mathematicians all lived in the 1700s. Let's study what they did there. I can tell you one thing they didn't do. They didn't have grade-based learning. They had mastery-based for these masters. Subscribe for more, and have a blessed day. Are you looking for an elementary math curriculum or pre-algebra curriculum that will help your child to master concepts in addition, subtraction, multiplication, and division, integers, fractions, decimals, percents, ratios, and proportions? Basically, first grade to seventh grade condensed into one course. I have that for you in a 48 video series course. So reach out to amosthemathguy.com, amosthemathguy.com. My course is on sale right now. You can get it and basically use it for the summer as well as all of the school year next year. By buying the course, you get access to a collaborative space where you can ask questions. We can have group meetings where we meet with other students doing pre-algebra. So please reach out. First grade through seventh grade math. I have your math that you need. We use Singapore math, the non-Common Core. We don't follow Common Core at all. We follow mastery-based learning because that's the way math is. And so we want to help your child learn how to master arithmetic and everything related to pre-algebra so they go into algebra with comfort. In today's video, we're going to be integrating some mathematics and chemistry into one lecture. We're going to be talking about this topic of variation in mathematics, and we're going to tie it back to Boyle's law, which teaches us about inverse relationships. Before we do that, let's talk about Robert Boyle. Who was Robert Boyle? I'm going to say a little bit about him now, and then we'll come back and say more about him later. Robert Boyle is known for Boyle's law. He was born in 1627, and he lived till 1691. He was born around the time Galileo was doing work in astronomy. This is a very important time in the scientific revolution. Isaac Newton had not been born at this time. Newton was born in 1642. But Robert Boyle grew up. He was blessed to have the means to attend good programs and get a good education. He was the 14th child and the last son of Richard Boyle, the wealthy Earl of Cork. Boyle's mother, the beautiful Catherine Fenton, died when Robert, like his contemporary Blaise Pascal, was only 3. But young Robert never knew the lady. Already the Earl had sent Boyle away from their Irish estate, Lismore, determined not to spoil him. At 5, in keeping with his father's bizarre ideas of child-rearing, the lad returned to Lismore, turned from the nurse who had been mother to him, there to begin his education. His father provided him with a French tutor, and the family chaplain taught him Latin. It's important that we learn another language, by the way. People need to learn a second language. I think that's just critical. We will talk more about the history of Robert Boyle. We'll have a whole video dedicated to him. But what's interesting is right before Robert Boyle is born, let's write the year down. He was born in 1627. He lived till 1691. But there was another man who we have a video on our channel whose name was Pascal. Pascal was born in 1623 and he lived to 1662. Here's what's interesting. When you live in life, when you begin to exist, is actually very important. Why is this important? Because in my video on Blaise Pascal, I told you guys that Blaise Pascal, the unit of pressure is Pascal, and Pascal gave us the modern syringe, that prototype. Not only did he do that, he also gave us the calculating machine that has affected some of our work in computer science. Why is this interesting? Because Boyle's law says that the pressure of a gas is inversely proportional to its volume. What that means is that if you were to increase the pressure of the gas, the volume will decrease. If you were to increase pressure, the volume will decrease. And if you were to decrease pressure, the volume will increase. That's called an inverse relationship. There's a direct relationship called Charles' law. That's another day's topic. But what I want to do now is, in keeping with our series, we have an algebra series. We have a pre-algebra, algebra 1, algebra 2, geometry, pre-calculus, calc 1, calc 2, differential equations. We have 21 college math credits. If you want it, reach out to amosthemathguy@gmail.com. In a partnership with a university, we're able to provide guidance to get college credit for math, science, English, history, and much more. So reach out to Amos, the STEM guy, @gmail.com, or amosthemathguy@gmail.com. Both of them come to me. One is focused on math, one is focused on science. It doesn't matter. Just send me an email and I'll get you the resources that you need. But here's what's interesting about Boyle's law. We're going to tie it to some algebra. This relationship here is written as K over V. Whenever you introduce an equal sign, you get K over V. So then K is equal to P times V. That is the relationship between pressure and volume in the form of a constant of proportionality. So then how do we do Boyle's law, work with Boyle's law? Well, based on this information here, P1 times V1 is equal to P2 times V2. That's the relationship that exists between pressure and volume in an equation format. Now, there are careers that use this, and we teach career planning, so reach out to amosthestemguy@gmail.com for that. This summer, I'm doing a career planning course for teenagers from around the world. Reach out if you have questions. What I'm doing is I'm showing you different careers and how it all connects to what you're learning in math. If you don't mind, I'm going to clean the left side of the board, and we're going to do an example. And we're going to use Pascal as our unit for pressure. So if you have P1 is equal to, let's say 10 Pascal, or kilopascal, and V1 is equal to 1,000 liters, and P2 is equal to 5 kilopascal, what is the volume in this particular system? Okay, I just made up these numbers for this example. So those of you who are chemical engineers there, calm down, okay? I don't know if you see these in your oil refineries, but you guys get the gist. P1, and I'm sorry for the reflection, P1 is equal to 10 kilopascal, V1 is equal to 1,000 liters. By the way, you should have a notebook or a folder where you can follow and show your work, and then send me your work and I'll send you a free copy of my book, Tools for Master Mathematics. So let's make sure that you're taking good notes. That's part of what helped Michael Faraday get far in life. Take good notes. Okay, so we have these details here. How do we find V2? Well, the first thing you should always do with any equation in science, whenever you're asked to find a missing variable, is write the formula out. Write the formula out. So you've written out the formula. Now, what do we know? We know P1, V1, and P2. Excellent. What are we solving for? V2. See the series of questions we're asking? What do we know? What formula do we need? How do we go from there? We solve for V2. How do we solve for V2? We divide both sides by P2. Whatever you do to the left, you have to do to the right. What does this mean? Because we want to cancel P2, we divide by P2, but if we do that to the right side, we also have to do that to the left side. This is called a literal equation or an abstract equation or just an equation with formula or formulas that you're solving for an unknown. In Nigeria, they will say changing the subject of the formula. So here we have V2 is equal to P1 times V1 over P2. So now we substitute the values in for what we have above. So what do we have? We have P1, which is 10 kilopascal. We have V1, which is 1,000 liters. We have P2, which is 5 kilopascal. Notice the kilopascals cancel. 5 goes into 10 two times. 2 times 1,000. V2 is 2,000 liters. Sorry, I started writing that out again. So that's 2,000 liters. Okay. V2 is 2,000 liters, and we have solved for V2. Subscribe for more videos, and remember, head on to Amos the Math Guy on YouTube to get more videos on the history and philosophy of science. Have a blessed day. Thanks for watching that episode. I hope you were encouraged to learn more about the history and philosophy of math and science. I hope you learned some math concepts to help you along the way. We will continue broadcasting Mondays through Fridays, 11 a.m. You will be seeing regular episodes where we talk about how to help your child flourish in math and science and life, career preparation, and vision for life. I look forward to inspiring students from around the world to know science, math, philosophy, the history and philosophy of science, logic, and theology. Take care and have a blessed day. Subscribe for more.